आज आम पढ़ा एटॉमिक स्ट्रक्चर क्लास नंबर 10 एवं आर्टिकल रोचे एटॉमिक ऑर्बिटल। बिफोर क्लास रे आम डिस्कशन करते क्वांटम नंबर कौन, क्वांटम नंबर केते प्रकार, को क्वांटम नंबर एवं तापर आम डिटेल डिस्क्रिप्शन करते। आज आम जा एटॉमिक ऑर्बिटल। एटॉमिक ऑर्बिटल उपरे जस्ट आम टिके कॉन्सेप्ट रखी पूर्व क्लास रे जे एटॉमिक ऑर्बिटल आम क्या कहबा एवं एटॉमिक ऑर्बिटल केते प्रकार। टिके आम खाली एतिक जानबो जे के सेल रो गोटे सबसेल दैट इज एस रिप्रेजेंटेड एज 1s, L can have 2s, 2p, M can have 3s, 3p, 3d, N can have 4s, 4p, 4d, 4m. Now atomic orbital definition हमें पूर्वरु कहिचे मध्य the probability of finding the electron density is maximum in which region around the nucleus of an atom is called atomic orbital. The probability of finding आमे तो atom तो केबे आमे देखी ना हूँ, सेल भी केबे आमे देखी ना हूँ, इलेक्ट्रॉन भी केबे आमे देखी ना हूँ, इलेक्ट्रॉन डेंसिटी भी संभव नुह आम मानक पाई। तेणु से आम कहे जितेबले न्यूक्लियस चारिपटे इलेक्ट्रॉन टे एलिप्टिकल पाथ रे घुरुछि, द डिस्टेंस बिटवीन न्यूक्लियस एंड इलेक्ट्रॉन प्रेजेंट इन ए सेल शुड नॉट बी सेम, देयरफॉर द फोर्स ऑफ अट्रैक्शन मस्ट बी डिफरेंट एट ईच पोजीशन इन द सेल। As the force of attraction is different, therefore the electron density is also different. The density in which place is maximum, that is called atomic orbital. Then definition क्या में जिबा the probability of finding the electron density is maximum, electron density is maximum in which region around the nucleus of an atom is called atomic orbital. That is the definition for atomic orbital. Now the electron density can be arranged in a cell in 4 different ways. That electron density may be spherically symmetrical or dumbbell arrangement or a double arrangement or a triple double arrangement. Therefore atomic orbital can be classified into 4 types. That is s orbital, second one is p orbital, third one is d orbital, fourth one is f orbital. Now the s, p, d, f are the called subcell, and also you can know these are the orbital. Now detail describe about s, p and d and f orbital. Now first goes to s orbital. प्रथम आम जा एस ऑर्बिटल विषय आम टिके जानिबा। s orbital देख रे प्रत्येक सेल के सेल हो एल सेल हो एम सेल हो एन सेल हो जो सेल भी हो प्रत्येक देख गोटे लेखा एस निश्चित आमको रही एमिति कौन सी एक सेल नहीं जो थे एस सब सेल नथिबो तेणु एस सब सेल बा एस ऑर्बिटल मस्ट बी प्रेजेंट इन एवरी प्रिंसिपल सेल KLMN are known as principal cell. SPDF are actually known as subcell. Now, first point, there will be one S subcell present in every principal cell. Every principal cell बुझे तेणु प्रत्येक प्रिंसिपल सेल निश्चित एस सब सेलटे रही थी नाउ सेकेंड पॉइंट द वैल्यू ऑफ azimuthal quantum number is 0 that is L equal to 0 S subcell पाई क्वांटम नंबर रो जानिछ the value for L is 0 so the number of orbital can be calculated by the relation m equal to 2l plus 1 यही फॉर्मूला द्वारा you know how many orbitals are present in a subcell. Now equal to 2 into 0 plus 1 equal to 1. Now this value shows a subcell containing one orbital. That orbital is itself. Now S is called subcell. S is also known as orbital. And what is the value for S? आमे कोटिए पाई पाले. What is the value for magnetic quantum number for S orbital? The value for S orbital is m equal to minus L to 0 to plus L, that is minus 0 to 0, that is plus 0 equal to 0. Therefore the value of azimuthal quantum number for S subcell is L equal to 0. The value of magnetic quantum number for S orbital is also 0. The shape of S subcell, or S orbital is spherically symmetrical and non-directional. Spherically symmetrical and non-directional. तेणु एस सबसेल हो बा एस ऑर्बिटल हो तार सेफ्टी कौन कहबा स्पेरिकली सिमेट्रिकल एंड नॉन डायरेक्शनल. तो एस एवं एठी हम कहता इट कैन बी रिप्रेजेंटेड एज देखा हमें एस सबसेल हो बा एस ऑर्बिटल डायग्रामेटिक हेले हमें ऑर्बिटल मीन्स दिस इज ए 3-dimensional पिक्चर and it should contain 3 dimension or 3 axes. Therefore now the shape for S orbital is spherically symmetrical. This is the shape for S subcell or S orbital. Means x-axis जेतिक डिस्टेंस y एक्सिस सेतिक z एक्सिस सेतिक therefore it is called non directional. Suppose this is the shape for 1s, suppose then 2s 3s 4s. Here is the value for principal quantum number. The shape for s subshell is also spherically symmetrical, but the size becomes large. 1s 2s 3s 4s all are shape must be spherically symmetrical and non-directional, but the size becomes large. On increasing the value of a principal quantum number, the size for s subshell or s orbital becomes increases. Then the higher s orbital are also spherically symmetrical and non-directional but the volume becomes large. Then the higher s orbital means 2s 3s 4s. Higher s orbital are also spherically symmetrical and non-directional, but the volume becomes large and can be represented as higher s orbital गुड़िक आम रिप्रेजेंटेशन करि परिबा Suppose this is the figure for 1s orbital. Now this is 1s. When you can draw 2s orbital figure x, y, z. Now this is the figure or shape for 2s orbital. Similarly for 3s orbital, orbital जिते आमर प्रिंसिपल क्वांटम नंबर वैल्यूटी बढ़ुथब सेते साइज एस ऑर्बिटल कौन हम इनक्रीज हो. नेक्स्ट द रीजन प्रेजेंट in between the sphere in which electron density value is 0, in which electron density value is 0 is called nodal plane or nodal region. आम देखिपर स्पीयर मान भितर एमती किसी एरिया थाए, एमती किसी जगह थाए, स्पेस थाए जो जगार इलेक्ट्रॉन डेंसिटी वैल्यू 0. इलेक्ट्रॉन डेंसिटी वैल्यू 0 हेले ताको आमे परिचय दो नोडाल प्लेन बा कही था नोडाल रीजन बोली. This is called nodal plane or nodal region. Now how to calculate the number of a nodal plane or nodal region for s subshell or s orbital. The number of nodal plane can be calculated by the relation n-1 rule. यही फॉर्मूला आम कौन करिपरिबा केतटा नोडाल प्लेन अच्छे आम डिटरमाइन करिपरिबा। नाउ फॉर 1s 2s 3s 4s नाउ n-1 means 1 minus 1 0 1s रो नोडाल प्लेन नाही जेते स्पेस अच्छी जेते जगह अच्छी सब जगह इलेक्ट्रॉन डेंसिटी रही। बट इन केस ऑफ 2s 2 minus 1 nodal plane, that one nodal plane will occur in between first sphere and second sphere means this area. Similarly for 3s 3 minus 1 that is 2, this is one nodal plane, this is the second nodal plane. Similarly you can calculate 4s that is 3 nodal plane, that is first sphere second sphere third sphere and fourth sphere. Now this is the idea about s orbital or s subshell. This shape for s subshell or s orbital can be calculated by a quantum number that is known as azimuthal quantum number. Any shape of orbital, any shape of subshell should determined by azimuthal quantum number. Now next आमे डिस्कशन करिबा p orbital विषय। p orbital देखो छुआ 1p अछि करे बाबू केभे नथिबो फर्स्ट सेल ले के सेल ले केभे p आसीबो नाही बिकॉज़ द के सेल for principal quantum number value is 1, that means it containing one subshell that is S subshell, therefore K cell have no P subshell present, that can have only S subshell present. Except K cell, other cells who containing P subshell 2p 3p 4p. तो आम प्रथम कहवा there will be one p subshell present in every principal cell except first principal cell. प्रथम प्रिंसिपल सेल को आम बाद पकई दबा तापर जेते आसीबो p रहिबो। सेकंड पॉइंट द वैल्यू ऑफ azimuthal quantum number for p subshell is l equal to 1. क्वांटम नंबर आम जानी s पाई 0 p पाई 1 d पाई 2 f पाई 3. The number of orbital can be calculated by the relation m equal to 2l plus 1, that is 2 into 1 plus 1 equal to 3. Now this value shows p subshell containing 3 related orbital. Next, what are the values for related orbital and what are the name? The values for 3 orbital can be calculated by the relation m equal to minus l to 0 to plus l, that is minus 1 to 0 to plus 1. Value are minus 1 0 plus 1. These 3 value, the 3 value indicates p subshell containing 3 related orbital, and such 3 related orbital are named as px, py and pz. Now these three value indicates p subcell containing three related orbital such are named as px, py and pz. The shape for p subcell or p orbital is dumbbell shape. The shape for p subcell or p orbital is dumbbell shape and represented H जो आम तीन ऑर्बिटल पाइचे px, py, pz आम ताको रिप्रेजेंट करि परिबा. Now this is x axis, this is y, this is z axis. This is x axis, this is y, this is z. This is x axis, y, this is z. Now when the dumbbell lies along x axis, then it is called px. Now this is called one lobe, LOB. This is called another lobe. One lobe lies above the plane, that it can be represented by sign plus. Another lobe lies opposite side the plane, that is represented as minus. This is called px. Similarly, when dumbbell lies along y axis, then it is called py. When dumbbell lies along z axis, that is called pz. Now three orbital can be represented by letter px, py, pz, and also this shape represented in this manner. As the three axes are perpendicular with each other, so the three p orbital are also perpendicular with each other. The three p orbital are perpendicular to each other. कहीं ना आम जाचु तीनटा एक्सिस परस्पर परपेंडिकुलर, तीनटा एक्सिस रे तीनटा रहा ऑर्बिटल, तो निश्चित से माने कौन है परपेंडिकुलर. द शेप फॉर हायर p orbital also dumbbell shape, but size becomes large. जिते पी आसो समस्तर सेफ्टी दीटा लोब को लेके हम, दैट इज कॉल्ड डम्बल शेप, but the size becomes large. एठी मध्य हमें पाई परिबा the region present in between the lobe in which electron density is zero, called nodal plane. The region present in between the lobe means dumbbell one side is called one lobe, another side is called another lobe, in which the electron density is zero is called nodal plane or nodal region. The number of nodal plane can be calculated by the relation n minus l minus 1 rule. This is the rule can be used to determine the number of a nodal plane for p subcell or p orbital. Suppose that is 2p, 3p, 4p. Now 2 means n value 2, p by l value that is 1, 2 minus 1 equal to 0. 2p रो nodal plane रहिबो नाही. Then 3p, 3 minus 1 equal to 1 nodal plane. 4 minus 1 equal to 2 nodal plane. For s subcell or s orbital, the number of a nodal plane can be calculated by n minus 1 rule, but for p subcell or p orbital, the number of a nodal plane can be calculated by the formula n minus l minus 1 rule. तो आज आम ये एस आ पी ऑर्बिटल विषय आम डिस्कसन कले. नेक्स्ट क्लास आम देखा जे तुम डी ऑर्बिटल एवं एफ ऑर्बिटल विषय आम डिस्क्राइब करवा. आज ये थैंक यू.